Hello friends, in this video we are going to discuss about the early effect on the bipolar junction transistor. So for this, let us take a PNP transistor. So for that, we know that a PNP transistor will have the emitter region P plus 2P and the base region will be N plus 2P and the P region, the collector region will be the P2P. So we can say this is the emitter terminal, this is the collector terminal, and this is the base terminal. Now, to make this transistor to operate in the active region, we have to give the potential such a way that the emitter will be the positive polarity. So it is the positive polarity and it will be the negative polarity. So I will connect like this. Let us say that this is the VEB potential applied. Similarly, if we apply the collector as a negative potential and the base as a positive potential like this potential, if we denote it as VBC, for this we can say the junction, that is the emitter junction here, that is the JE junction, will be forward bias and the JC junction here will be reverse bias. Since the JE junction will be forward bias, so we can say that the depletion region will be thin in the JE junction. This is the depletion region which is very thin at the JE junction, and the depletion region will be thicker at the JC junction because the JC junction is reverse bias by the potential that we have applied between the collector and the base. So these are the two depletion regions. Now let us assume that if we increase this reverse bias potential, if we increase the base to collector voltage, then we can say that the reverse bias potential at the JC junction will be increased. Since the reverse bias potential at the JC junction will increase, so the width of the depletion region at JC will be increased. So we can say that if this is the width of the depletion region, then we can say that this is the WT, that is the width of the depletion region. So this width of the depletion region will increase. So let us assume that we have applied a potential VBC1 right now, where the VBC1 is greater than the previous voltage VBC. In this case, the depletion region will be enlarged. This will be the depletion region width. So let us assume that the depletion region width has been increased due to the increase in the reverse bias potential at PBC. So right now the depletion region width is this one, that is WD1, and WD1 is greater than WD. So in this way we can see that when the potential was VBC, the effective base width was this one. This was the effective base width WB. Right now, when we have applied the potential VBC1, our depletion width has been increased to WD1, so the effective base width has been decreased. In this way, we can modulate the width of the base region by applying the VBC potential. So we can write that by applying VBC potential, the width of the base region can be changed. Since the base region width can be changed by the VBC, we can say that this phenomena of controlling the width of the base region is called base width modulation. This base width modulation is also called as the early effect in the BJT. So this is all about the early effect in the BJT, and for finding the early effect, we know that we have to control the VBC potential, because this VBC potential will control the width of the depletion region at the JC junction, which in turn control the effective base width of the transistor. This is all about the early effect in the BJT. Thank you.